Finding the slope of a line. Slope is a measure of the slant of a line. It describes the steepness of the line. The letter M is used to represent slope. We can look at slope as the ratio of vertical change of a line compared to horizontal change. This is sometimes referred to as the rise over the run. We can find slope three ways depending on what we are given. We can find it from the picture, from the equation, or given 2 points that are on the line. First, we'll find the slope of the line given the picture. Let's find the slope of the line given 2 points. We need to find points that hit at the corners so that we're going to use a whole unit. We could use any of these points. We only need 2 points. So let's use this point and this one, and we'll start here and move to the other point. So we're going to go up 1, 2, 3 spaces. Going up is positive, down would be negative, and then we're going to go to the left 1, 2 spaces. To the left is negative, to the right would be positive. Let's see what would happen if we went in the other direction. So say we started at this point and moved to the other one. So first we would do our vertical change. We're going to have to go down 1, 2, 3 spaces. Going down is negative. And then we would go to the right 1, 2 spaces. To the right is positive. These two are equal. You have 3 over 2 and only one negative. It does not matter where you put the negative. Let's try it with these points that are farther apart. So we'll start here and move to this other point. First we'll do vertical change. To get from here to this point we'll have to go up or rise 1, 2, 3, 4, 5, 6 spaces. That would be vertical change. It will be positive 6. Then we'll have to go to the left 1, 2, 3, 4 spaces. Going to the left is negative. And we could reduce these. They have a common factor of 2. 2 will go into 6 3 times, and 2 will go into 4 2 times. Let's look at finding the slope of the line given an equation. If we have a certain form of the equation of the line, we can find the slope easily. And that form is called the slope-intercept form of the line. It has y isolated. In this form, the slope is the coefficient of the x. Let's look at some examples and pick off the slope. Notice all of these have the y isolated, so they are in slope-intercept form. In the first one, the slope is going to be 2. 2 is the coefficient of the x. In the second one, the slope is negative 3. The sign, remember, is part of the coefficient. And in our third example, the slope is negative 3/4. So we can easily pick off the slope as long as the y is isolated. Some other information that we can easily pick off from this form of the line is the y-intercept. And it is the b. Remember, to find the y-intercept, we plug a 0 into x. If you put 0 into x, it would make this piece disappear. Giving just y equals b. So we can pick off our y-intercept as the b. So for our first example, our y-intercept is going to be negative 5. The coordinates will be 0, negative 5. For the second one, the y-intercept will be 2. Coordinates are 0, 2. And for the third one, the y-intercept will be -1. Coordinate is 0, -1. Let's look at finding the slope of this line. Notice it's not in the proper form. It does not have y isolated, so we can't read the slope directly off. But we can use our formula solving skills to manipulate it and isolate the y. So we want to get y by itself. We'll move the 4x. It's a positive 4x, so we'll take it away. If we take it away from the left-hand side, it will cancel to leave us just a -3y. And then we will also need to take it away on the other side. Then we'll go back on this side with the y, and we need to divide out the -3. One thing that's a little different from formula solving is we're going to divide it under each piece instead of just under the entire side. So we'll divide on both sides by the -3, but under each piece. Then we'll clean up. Notice you can clean up your signs on your slope. 2 negatives will give you a positive, and you can pull the coefficient away from the x. Now we can read off the slope. The slope is the coefficient of the x. It does not matter that the order has changed. So slope is 4/3. If we were asked for the y-intercept, we could also pick it off. It will be the -7/3. And remember, for y-intercept, the x-coordinate is 0. Next, we'll look at finding the slope of the line given 2 points. Each point gets an x and a y, but would like to tell those apart. So we'll label them with subscripts. We'll call this one point 1, and we'll label it with x1, y1, and we'll label the other one x2, y2. Remember that we can look at slope as a ratio of the vertical change compared to the horizontal change of the line. Which variable has to do with vertical movement? It is the y variable. And if we want to find the change in the y variable, we could subtract them. So we will subtract our y coordinates to get our vertical change. The x is the variable that has to do with horizontal movement. So to find the horizontal change, we'll subtract the x's. We need to go in the same direction that we did for the y's. It is standard to see it with the second one first. It doesn't matter as long as you go in the same direction for the x's and the y's. Let's find the slope of the line through these 2 points. First, I would label the points. This will be x1, y1, and this will be x2, y2. And then we'll substitute into the formula. For y2, we have 3 minus, from the formula, y1 is 5 over x2, which is 2, minus from the formula. And notice x1 is a -4. Don't lose a sign. This minus is from the formula. We're plugging in a negative. So we'll use parentheses. And then we'll clean up. So on the numerator, 3 minus 5, or 3 and a -5, gives us -2. The denominator, minus a negative or opposite of negative, gives us plus. So we have 2 plus 4 gives us 6. And we can reduce. We only have one negative, so it will be negative. And we have a common factor of 2. 2 goes into 2 one time, and 2 into 6 will go 3 times.